Welcome back to class, dear students. In this lesson, we are going to talk about unlocking the potential of blockchain technology as you start your journey to become a Web3 blockchain developer, smart contract developer. These are things you need to know about blockchain, at least those basic things. And as you immerse yourself into it, which is the first advice, is if you want to be a blockchain developer, you can't be an app developer, like Android app developer, when you have never used Android app before. Maybe you are just fan of iOS app. Once you want to develop for apps for the Android, you need to at least get an Android phone, get 1, 2, 3 or some apps, test them and see things. So that is my personal recommendation for you, because the more you get used to using blockchain, dApps, wallets, smart contracts, different platforms that relate to Web3, the more you will get closer, you will understand the pain points, the opportunities, the challenges, and the more, the better you will be at, creating dApps that solve those problems, and which translate to you being able to earn even more better as a Web3 developer. So that's the first thing you should do in order to know. And before you now jump in, I want to use this lesson to give you a brief overview of some things you will likely come across, so you don't get confused what each of them represent when you talk about blockchain. So the first one is, we'll talk about understanding the blockchain. So we want to look at the basic concept, learn how blocks are created and maintained, explore the various types of blockchains and their consensus mechanism, understand the security aspect of blockchain technology, appreciate the benefit of blockchain over traditional, and types of like blockchain developer that exist. Which one will you like to be? So I want to run through all of this for you step by step. So when I talk about understanding what's the blockchain, blockchain is a distributed ledger known for its ability to maintain a secure and decentralized record. Each block in the chain contains several transactions, and every time a new transaction occurs on the blockchain, a record of that transaction is added to every participant's ledger. So what this means is that when you talk about the blockchain is, you have a single block, a kind of a block. Let me pull this up. Let's say this is a block for us. You have this now. So inside this block, you have different things which could be, let's look at different things like what we know as transaction, which could be from like maybe smart contracts, tokens, which could be like non-fungible token, NFT, maybe DeFi projects, whatever. A lot of all these transactions, everything bundled together will come into this block. Now, once this block has all those transactions, go through some verifications or mechanism we still learn about. The next thing that it will do is, you have something like this. You have something like this being created. You can see it. So you have all of this now already joined together. Here you can see it now that we have something like this being chained together. And once all these are bundled in this, then it goes here again, get to fill this. So that's where the word for block chains. So that's a chain of block that's connected. They keep getting added, keep getting added, keep getting added. The more there's need to be, the more that will be added. You can see it. So it goes through a lot of all those things here, and then before you know it, this will be like block 1, block 1, block 2, block 3, then block 4, and then so on and so on and so on like that. You can see it now. So each, that's why the chain of blocks that brought about the block chain. So those transactions keep, and once this transaction is keyed in here, you cannot change it again. That's part of the advantage. Nobody can go back, because the way they were done, if you look at this now, if you go and remove anything here, you will crash the rest, because they depend on each other, and you will discover how they do that using what is called the security hash, how it is being hashed and all those things. So we learn those basic in this lesson. So at least this has given you the basic something. Let's call this nodes. Yeah, let's call this nodes. You can see it now. Then we have transaction, a lot of other things you can see. They all go through the nodes for that particular blockchain, and then you can be able to have this. Let's take this blockchain. Yeah, cool. Now once we have this, so we have the blockchain here. You can see the nodes and all those things. So that's how brought about. And let's quickly get through to other part of the lesson. So you have an understanding of it now. So how is it being created and the maintenance? You have also seen that the block accumulates information in groups known as blocks. The old set of information. Block have certain storage capability. When fields are closed and linked to the previous field block, forming a chain of data known as blockchain. That was what I've drew out for you here. So then we have new information. The freshly added block is compiled into a new form block, which is then also added to the chain once filled. Now you will wonder, how is it now being secured? Can't somebody just go and add blocks and all those things? So those are the things you will still learn as well. This, when you talk about types of blockchain by accessibility, we have private blockchain, public blockchain, and like maybe a consortium. The private blockchain, which is popularly what we know like Bitcoin, Ethereum, Solana, and the likes like that, are the blockchain that is accessible for everybody, and usually their transactions are public. So you can go online and check the transaction through their explorer and have access to them. So, but there are some that are private blockchains. Those are not usually popular. They came after the public for specific organization to use blockchain without risking the issue of getting their users' data exposed publicly. And also the consortium operated by a group of organizations. So each of them serve their own purpose. We have types of blockchain by smart contract. So we can also group it based on smart contract. This blockchain, like I've showed you here, you see smart contract. Not every of these blockchain has this smart contract. We'll still learn about smart contracts in details in the next lesson. But these are code that run. They are part of everything you see here. They are code. Either is NFT, DeFi, platform, token, whatever it is, they are code. The blockchain see them as a code. So the aspect of a code that make you do a lot of things, except for basic transaction, like you have a Bitcoin now, you want to send it to somebody or you want to receive it. Apart from that basic, you need smart contract to expand the functionality, which then allow people to deploy their own custom token, their own NFT, their own DeFi platform, their own exchange, and a lot more things like that. So all those things you need smart contract to get it done. So there are types of smart contracts which can base blockchain, which we call EVM smart contract blockchain, which these allow smart contract compatible with Ethereum virtual machine. So we'll still learn about Ethereum, just get it, give that idea at that level. What brought about the Ethereum virtual machine, we'll still learn about it in coming lessons. So then we have the non-EVM, those that are not compatible with that EVM Ethereum virtual machine, like Solana, Polkadot, ICP, Flow blockchain, and a lot more like that. All these blockchains usually have their own specific smart contract programming language. Like Solana use Rust majorly, though it's now open to Solidity. That's why one of the reasons why it was featured here in this course, so that you can know the benefit. Because the main something we are focusing on, at least for now on DPU, is Solidity. So in future we can expand to others, but at least for now, because it has a lot of advantage learning it as a smart contract or theory developer. So those are the differences. Then we talk about blockchain consensus mechanism. So consensus means how people come together. How does those blocks come together to reach agreement that, okay, this block is valid, add it here. If there is no consensus, it means anybody can just create their block and just add it. No, there has to be consensus that, okay, for every player, everyone involved, which we call them miners, for all those things, they have to know that, okay, we need to agree. So all those set of things, like this node, are like small computers. Look at it like servers that hold all these transactions and everything, and add the blocks to make them available all over the world. So there are different consensus. We have popular ones are POW and POS, POW and POS. So when you look at POS, means proof of work, and then proof of stake. So proof of work requires a significant amount of computation power to validate transaction, while POW offer a more energy efficient. So this note now, for them to be able to be the one to create the next block, they need to do some mathematical calculation, trying to figure out some things set by agreed rules on like Bitcoin blockchain. So if you are the first miner that figured that out, then the transaction, the block, you mine the next block and it gets added. So at the same time, you get a reward in Bitcoin and all those things like that. So when you look at other blockchain like Ethereum, or Solana, which are now proof of stake, instead of like mining, you stake token. So the more stakes, the more the opportunity to, be the one to mine. But you look at, people can be rich and just stake. No, there is a way they do it. It's not like because you now have the biggest stake, then automatically you just be the only one mining. No. And at the same time, I think most of these blockchain try to limit the maximum. So for example, even if you have the money, there is a max that the node stake, the stake can be. Once it reaches, you have to shed it to other. So that enforces to minimize the chances of just somebody buying up all those things, to make sure the blockchain keep decentralized. So there are a lot of debate on that anyway, but those are the things. Then you have security in blockchain. Blockchain technology is lauded for its security. It uses cryptographic hashing to secure the data within the blockchain. This, along with decentralized nature of the block technology, makes blockchain immutable. You also learn about the cryptographic hash we call like blockchain Bitcoin use 256. So you will learn about it more under each of those blockchain, which we still have the lesson they are right here for you. So for now, just know that those things are being secured so that nobody can just take block at it. Then nobody can come and remove any of this block, because each of these, for example, now when this transaction is done, it is passed through that security hash, and a hash is gotten, which is this, to create and connect with this. So now, if this hash that link both of them, if I come here, the hash work like when you put in all these things here, it gives you this particular block 4. If I change just this T, I remove this T and I change it like this, it will change everything, and this will no more be block 4. You understand? And then instantly we know that something is wrong. So that is why that hash preserve the trustworthiness without human interference. That okay, because once you change a letter, it's coming through that hash, it form an total output of hash entirely. So if this come out and form block 4, the moment you change just that T or you put space, forget it, this could turn to block 56, which now what we need is block 4. So it invalidates that. The malicious miner can be punished by slashing their stake and some things like that. You understand? So that's how those things are kept secret. Don't worry, with time you get to wrap your head around all these things. So, and then we have gas fees and blockchain security. The gas fee in blockchain acts as transaction fee that user pay to miner or validator to process. So, you know, we've learned that people is either they are using their computational data or server and all those things, or staking their token. Either of it, some people put in investment in time, in money to run those nodes and all those things. So they need to be rewarded. 1, to encourage them to keep. 2, to keep things decentralized, because once there is a reward, more people will be encouraged in different continents, and so those things will be decentralized all over the world. Then the third thing is it prevents people spamming the blockchain, because when your transaction will be paid for, the chances, you can imagine people that go to like Twitter and all those platforms and spam with posts. Assuming for each of those posts, they have to pay transaction fee. Do you know that automatically 90% of spam on those social media platforms will disappear? 90, if not 99%, because you can do a post and instantly somebody can do 20, 50 spam response on it. You don't understand? So you cannot imagine if they have to pay for each of those. So all those things are part of the security that we put in this design. We'll still learn about the founders of this blockchain and others in each of those individual blockchain later down the line. So that gas fee, you need to pay it each time. So keep that in mind. Then cryptocurrency, understanding its relation to blockchain. So the cryptocurrency, is created the block through cryptographic. So that's why the currency on it, which are like the token, we still learn the differences. That's why it's called cryptocurrency. That's cryptographic currency. This is different from just any digital currency you have in your bank account that you transfer, because this one is created cryptographically. There can only be maximum of it per time based on like Bitcoin, and there can only be 21 million and things like that. So all those things are what makes it different. That's why it's called cryptocurrency. not just digital coins, because that one is just digital centralized server. People can just change it here and there. No, you can. This one are guided by set of rules on the blockchain. So then types of token we have there. The types of token on the blockchain, we have fungible token and non-fungible, interchangeable and identical in value. So fungible token, like your dollar bill, if you have $50 bill, you can change it for two $20 bill and 10. That's the 50. You can give it to someone and they buy something of $10 bill, and the person give you change or balance of 40. But when you talk about non-fungible, like your card now, you can't take your card and exchange it for another card, even though they are all cards, and say they are still the same. No, they are individual and unique. Or you say, oh, let's take the hand. You take the hand, I take the leg, and we still have a full pet living. That's not possible. So they are non-fungible or non-fungible tokens. So that's why you use them for digital art, NFT, and a lot more like that. So note, native token of blockchain are usually referred to as coin. So Bitcoin is a coin, Ethereum is a coin, because it has its own blockchain. So it could be like Ethereum blockchain. The coin token used for gas fee and something like that is a coin, so to differentiate them. And the token are other tokens you can create within that blockchain. So as you learn more on these things. So it's just good. Pause, rewind. Having a rundown of all these things is essential. So we have the blockchain versus Web2. Blockchain has significant advantage over traditional Web2 technology, includes decentralized, transparency, immutability, and enhanced security. Like I've told you, all these things, because it's hashed. Even those that have it on their system, on their node, on their server, they cannot change, because once they change, it scatters everything and they'll be exposed. So compared to centralized server on Web2, like Facebook, all those things, Twitter, they can remove you anytime. They can just, whatever you've done, they can hide some things without even the public knowing, because the server is what? It's not decentralized. It's not, if you are not an employee and given the access, you don't even know what is going on there. So then the last part is types of blockchain developer. Now you have idea of blockchains, what it is, how it was revolutionizing from Web 2. We are saying Web 1, Web 2, Web 3. Now, types of blockchain developer. We have core blockchain developer. This with blockchain core development, harder to build the skill set and limited to specific blockchain opportunity, but pay the highest, because you have limited opportunity, but also require high skill. It's not something you just want to start and it takes a longer time. You understand? Usually maybe you are in Web 2 already a senior developer in core platform, working with OS and things like that, then you could transition to that. So then we have that blockchain developer. You build app, easier to build the skill. So like you are doing through these DPU courses, you are learning to be a dApp blockchain developer. So that one is much easier to learn this skill. When you learn some basic languages, you can start developing and start earning. You understand what I'm saying? Not until you become a senior developer or all those things. And you have unlimited opportunity. You can get hired, employed. You can start your own project. You can be a DAO with other projects. You get different opportunity. So you may earn less, but I tell you, even that earning is still far more than what normal Web 2 developer earns yearly. So then we have blockchain security developer. This also deals with security for dApp, the blockchain, to ensure everything is secure. These are the people that try to poke into the blockchain, poke into the dApps, and see if there's any security flaw and report it for bounty and things like that. So it's a bit harder as well to build this skill, but and also limited opportunity, but paid next to like core. When you do seeing a blockchain developer that discover a flaw and earned $1 million USD, for that bulk because it saved almost, I think, over 15, 20 to 30 million USD. That if he has exploited it as a black art, would have been able to see about 15 times of that or 30 times or even more of that. You understand what I'm saying? So it was compensated with that. So you can see, for you to earn that as a dab developer is not easy. You get so, but all these things, the skills. So we are focusing more on that blockchain developer. And as DPU, as time goes on, we could collaborate with more and get more courses on blockchain security and even maybe core blockchain developer. So you are on the journey for that blockchain developer or smart contract developer. So that's it. Hope you have learned a lot in this lesson. So we've learned and explore blockchain, what the blockchain technology is actually is, how it's done, how it's being secured, how it makes the Web3 world reality by decentralizing all these things, yet following set of rules that make it secure. You try to breach it, you get slashed, you get punished, you get kicked out. So all those things are what makes blockchain the building blocks of Web3 era. So that's it for this lesson. Don't forget, if you get stuck, you can always make use of the comment section and ask questions specific to this lesson under it. Other ones also have their own. Don't jump lessons together, so that we can help ourselves, the student, also other students will be able to learn from those things. So that's it. I remain Solomon Foske of the Programming University. Keep the programming spirit and life. Please always do good to humanity with your programming skill and not evil, to make the world a better place. Thank you and see you in the next lesson. Bye.